Hello, everyone, and thank you for joining me today for episode 868 of People Behind the Science. I'm Dr. Marie McNeely, and today we're excited to be rebroadcasting our interview with our guest, Dr. Ayse Turak. Listeners, Ayse develops and studies plastic-based electronic materials such as solar cells and light-emitting diodes. Her goal is to create affordable, sustainable, and ubiquitous plastic materials to provide power and light for people around the world. And in this episode, Ayse shares some wonderful stories about her life in science. So listeners, sit back and enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to be speaking with our guest researcher, Dr. Ayse Turak. So, Ayse, welcome to our show today. How are you?
I'm good. Thanks very much. It's exciting to be here, especially today. It's a beautiful day outside, so it's nice to be sitting at home talking to you.
Well, we are so excited to have you with us and to have the opportunity to learn more about you and your work. But before we dive into the details, let me first start by telling our listeners a little bit about you and your current position. So listeners, Ayse is Associate Professor and Associate Undergraduate Chair of the Department of Engineering Physics at McMaster University. She received her bachelor's degree in Metallurgical and Materials Engineering from Queen's University and her PhD from the Department of Materials Science and Engineering at the University of Toronto, where she was a Canada Graduate Scholar. Afterwards, Ayse conducted research as a Marie Curie Fellow at the Max Planck Institute for Metals Research, and she subsequently worked as a visiting professor at Sabanci University in Istanbul, Turkey, before joining the faculty there at McMaster University. Ayse has received numerous awards and honors throughout her career, including the Early Researcher Award, the Petro-Canada Young Innovators Award, and a Leadership in Teaching and Learning Fellowship from McMaster University. In addition, she was recently nominated as a full member of Sigma Xi, and she is the co-chair of the Canadian chapter of the Society of Information Display. And in our interview today, we are looking forward, Ayse, to learning more about you, more about your life, and more about your research. So can you start first by telling us what you like to do when you're not doing science and engineering?
Well, I like to do lots of things, but I do like to do a lot of science and engineering. But usually when I'm not sciencing, I like to travel mostly. I like to go to new places and see new things and have new cultures. My wife is Chinese, so we often go to China. We go around the world, visiting lots of places. So it's very exciting. That's really one of my favorite things. And we're kind of adventurous travelers. So we like to do cool things when we're abroad. And we go scubaing, for example. Our most recent trip was the best. We went to Yellowknife and did like an aurora visit. So we chased auroras around and watched the auroras and the northern lights. It was amazing. It was really cool. So we like to travel a lot. It's a lot of fun. And I mean, the other things I like to do, I'm really big into theater and writing, and I volunteer a lot with social justice organizations. So I was involved with Pride Toronto for a number of years, and I sat on the board of Buddies in Bad Times Theater, which is a theater in Toronto. So I like to do lots of stuff.
Well, it sounds like you've got quite a bit to keep you busy outside of your work, but I'd love to talk about your work as well. So Ayse, when you talk to people, and I imagine this happens every now and then, who maybe aren't familiar with your research field, aren't experts in the area, how do you describe what you do to them?
Officially, my title is a material scientist, and I'm an engineering physicist. And most people are like, what the hell are those things?
How did they go together?
How did they go together? The biggest way that I like to describe, particularly my research beyond those titles, right? So the work that I do specifically, which is I work in the world of organic electronics. So these are plastic-based electronic materials where we're trying to replace things like silicon for computer chips. And my main focus of my research is really on the use of plastics to power and light the world, I like to say. So I make solar cells and light-emitting diodes from different kind of plastic materials with a focus on trying to make them cheap and sustainable and basically ubiquitous. That's really my goal, is to just cover the world in solar cells so that we can have affordable energy forever. But in a broader sense, material science and engineering physics is really about exploring engineering problems or the problems of the world using the basis of physics. So using physical concepts, and material science is really a branch of physics, looking at atoms and molecules and how they fit together and how they interact with the world. So that's my two-pronged approach. My research is one way, but also the general field that I'm in is another one.
definitely. And you mentioned specifically sustainability. And I think right now there's a bit of a stigma against plastics. Is this something that's difficult for you to communicate how your work is important?
It is one of those ideas about plastics being petroleum derived and not sustainable in a lot of ways. And there's a lot of truth to that. But plastic is a really broad term and it applies to a lot of things. So when we talk about plastics, what we mean really are just different kinds of organic molecules. And the kind of organic molecules that we use, which are semiconducting organic molecules, a lot of them are derived from dyes, as well as they're sort of bio-inspired kind of things. So for example, one of the most common blue dyes, for example, everything that's colored blue in the world at this point is made using this dye. That's a semiconducting organic molecule that we work with. So it's called copper thiocylene. It's actually not derived from petroleum products. And another one that's very common, again, a blue. Lots of pigments tend to be quite active electronically because we're dealing with photovoltaic and light-emitting materials. So you need something that absorbs or emits in the blue or green or in the visible spectrum, right? So a lot of these materials were historically used as dyes for that reason, because they absorb strongly, for example. So another one is something called isoindigo, which is derived from the shells of shellfish. And that's also a semiconducting material that we work with. So plastic materials or organic materials really make up everything in the world. And petroleum also comes from those same materials, but also all the vegetable matter around us, all of the shells, all of the people, everything. So a lot of the materials we can use are what are called bio-inspired materials. So if you talk about it in that way, I like to use plastic as a shorthand just because it's something that people understand, but it's not the same as the shopping bag. It's not the same kind of material.
Well, thank you for giving us some insight into the work that you do. And I know you're working to achieve these big questions and working to advance in your field, but it can be difficult to find the motivation, I think, on some days. Sometimes you need a little bit of motivation and inspiration to get you going in the lab. So I love sharing quotes and sayings with our listeners that can help motivate, inspire all of us. So do you have a favorite one, Ayse, that you can share with us?
I don't really have a particular quote that I use to motivate myself, but I guess when I think about inspiring words, I really love Feynman's quote about there being lots of room at the bottom. So this was his inspiring description of nanotechnology and its potential in the future. And really, because I work in the nanoscale, I work with nanoparticles, for example. That's part of what we do is we incorporate nanoparticles with these plastic materials that we use. And I really feel like it's at the nanoscale where we can really start to change things. This is where material science and chemistry and physics and everything starts to collide, is when you're dealing with atoms themselves, placing them, manipulating them, allowing them to change the properties of something. So that's a big inspiration. This idea that these tiny little things can have huge impacts in the world.
Oh, definitely. Well, a phenomenal quote. And I think Richard Feynman is a giant in the field, an inspirational figure for so many people. Are there others, Ayse, who really motivated or inspired you or maybe mentored you along your journey?
There's too many to count, really. But I think my main role models in my life are my parents, actually. My father actually is also a scientist, but they were really the ones who encouraged my love of learning and of curiosity to be who I am and to aspire to be who I want to be. And they've been there every step of the way, sort of pushing me and keeping me going and motivating me all the time. And they really, I think, were my big role models in the world. But I think my scientific hero is Ursula Franklin. She's a metallurgist, and she actually was the first female full professor at U of T. Shockingly and shamefully, I would say in 1973. So this was the first female professor at U of T that was a full professor. Mm-hmm. And she wasn't only just a brilliant scientist. I mean, she did a lot of work in condensed matter physics, and she was a metallurgist by trade and worked in XRD and things like this, which were also obviously my passions. I mean, I learned about her first when I was doing metallurgical engineering at Queen's. She was a well-known figure in the field. But beyond that, she was also an activist working for women's equality, obviously, women in the sciences particularly, but also generally advancing the rights of women and girls around the world. And she was also a peace activist, and she was a very prolific writer and wrote on the sort of political and social effects of technology and how it changes the world and how we can use technology to improve society and social justice. So she's sort of inspiring both from a scientific perspective, but also just as a person who looked at the world as a place where, as a scientist or as a person really, you should always bring your best self to do the best you can to change the world.
Well, thank you for introducing all of us to Ursula. I look forward to reading up more about her and her contributions, both to science as well as the activism side. That's awesome.
She's very cool. It's really a crime, I think, that she's not more well known. I'm very proud to say when I was in undergrad, I did a minor in women's studies. And during that minor, we learned about her in a class on science technology. And it was like a science and philosophy class. And so she also came up there. So I thought it was amazing because I was learning metallurgy and then I was taking this women's studies class and she was in all these areas and it was super inspiring. I'm like, oh, this is amazing.
Oh, that's so cool. Well, we are helping spread the word. So, well, Ayse, thank you for talking about these inspirational figures in your life. And you mentioned your parents. I'd love to come back to them. You mentioned your father was a scientist. What kind of science?
He's a chemical engineer by training, but he ended up working in petroleum and coal. Actually, we moved to Canada when I was 3. So we immigrated from Turkey. We lived in Alberta, and Alberta's in the west, and it's the primary place where we have oil and gas. And it's a big industry around there. And he was working as a coal extraction engineer and looking at petroleum products and processing at the Alberta Research Council when I was a child. And then he ended up working for Alberta Energy, and he did a bunch of work, even in photovoltaics. I think in a lot of ways, he sort of prompted my interest in it. He always told me the story about he and his friends when they were at university in Turkey, they were always trying to design a solar powered cooler. This is what they wanted, was to have a beer cooler that had a solar panel on top so that they could cool their beer. And they would always tinker around with that kind of stuff. And he was always like, coal and oil and gas are the ultimate photovoltaic materials, right? It's just, it happened 1,000 years ago that it was all that energy from the sun was concentrated into this coal that we carry around. But he was very inspiring, someone who was always curious and pushing me to ask questions and think about things. And I always credit him for starting my interest in a lot of things, but especially in science.
Definitely. So do you remember when you started to maybe think a little bit more seriously about science and engineering and consider pursuing that path?
Well, actually, I planned to be an engineer when I was at like grade 3 or something. They ask you, what are you going to be when you grow up? And I was like, I'm going to be an engineer. And my father always has this great story. I would follow him around in his lab. I wasn't allowed to do anything fun, really. I mean, interfere with his science so much. But apparently his lab mates and his colleagues and stuff were always like, oh, he's our little scientist here. And they would like give me an experiment to do. And I would like play around with stuff. And I have all these different sizes of coal agglomerates still on my shelf that he gave me when I was 12 or something. So really from a young age, I was on my track to science. And I remember in junior high, I had a friend who her father was a professor at the University of Alberta in chemistry. And we were doing titrations in chemistry class in junior high. And just for fun, the two of us would go to his lab and like do titrations to practice.
Perfectionists, I like it.
Yeah, exactly. I was like, gotta get it right. But it was also really cool. I mean, I really enjoyed being in a chemistry lab and having all the different chemicals. And titration is pretty fun because in particular, we were looking at the potassium permanganate reaction. And so it's really cool where you drip some chemical into your solution and eventually it turns this bright purple. The wonder of chemistry. It was always really exciting because my father is a chemical engineer. And so he was always like, don't ever become a chemical engineer. So I was like, haha, I'll go into material science because it's like the closest I could get to chemical engineering without being in chemistry. But no, that's actually a joke. He was super supportive. And actually, I was planning to become an aeronautical engineer up until I went to university at Queen's. And I went to one class that was taught by this amazing ceramics professor at Queen's. And he passed away, sadly. But I don't know what it was about that class. It was during our first year chemistry class, and it was an optional lectures on material science. And most of my friends didn't bother to show up, but I was there and I was like, this is the coolest thing. I'm going to totally go into materials. So I like completely changed from going into aeronautics into materials. And then I'm still here. So it was the right choice.
That is amazing. So can you talk a little bit about, as you were maybe finishing up your bachelor's degree, what prompted you then to go get that PhD?
Again, I had from an early age decided I was going to get a PhD. That was never a question for me. I was always planning on doing it. And actually, my original plan was to finish my undergraduate work in the summer and then immediately go and start my graduate school. But my parents were like, what are you doing? Your whole life you're going to work. So you should take some time off and travel. And they gave me a little bit of money and I saved up all of my summer earnings from all of my summer jobs during my bachelor's. And I took 8 months off and traveled around Europe and Turkey and went and lived with my relatives that I hadn't seen in a long time. And then delayed my start to my program by about 8 or 9 months. So it was probably the best experience I could have ever had. And I'm really grateful to them that they were the kind of parents who were like, it'll still be there. Right. You can come back and do it.
Definitely. And I think for so many scientists out there, you look at this path ahead and it is a long journey from the start of the bachelor's degree all the way until you get a position, whether it's in academia or outside. And I think taking a break can really re-energize you and get you ready to tackle that next stage rather than pushing right through. But that's something that I think not nearly as many people do.
No, it's very true. I think I would recommend it. And the other thing that I would really recommend is I was very fortunate that after I finished graduate school, I had the opportunity to go to Germany on a postdoctoral fellowship to the Max Planck Institute. And that also was something that I thought was really energizing and amazing because it was getting out of North America. It was getting out of the same style of schooling that I had been in, right? The same kind of research labs. Every different lab is a different culture, but something about going abroad, like leaving North America, leaving the American system, leaving Canada, going to Europe and seeing how people do things there, or to Asia, I think it gives you a completely different perspective on both science and culture and yourself. And it's very energizing to go to these new places and explore new things and be out of your element. It sort of opens you up to the possibilities. I was a little burnt out, I would admit, after undergrad, as we all tend to be, because there's a point where you're like, oh my God, what am I doing? And same thing at the end of grad school. You're just like, oh, it's so long, so many years. What am I going to do with my life? And taking that time to sort of pause and reflect and take a break, and then before you go on to the next thing, I think is really great. I mean, I was very fortunate because in both of those instances, I'd kind of secured my position before I decided on my trip. So I knew I was going to grad school when I decided to take this time off, and they were gracious enough to give me a delayed acceptance kind of thing rather than starting in September. So it wasn't as risky as it might be for some people. I'm not advocating necessarily that you like throw caution to the wind completely and just ditch everything.
Sure.
But if you can take that kind of pause, it's really beneficial to ramp you up and get you energized again and back into the science. Sometimes from my travels, I really get inspired by the people that I meet and the things that I do. And sometimes it'll prompt new questions where you're like, I hadn't thought about doing something that way, or I didn't realize other people did this thing. And I can bring those kind of ideas back into my own research and be like, okay, well, what if we tried this now? Because I saw this thing that somebody was doing, and it really prompted me to think about the questions we're asking in a different way. So I feel like all of those experiences give you new insights into how to look at the world, how to look at problems.
Definitely. And I know Max Planck in particular is sort of a storied set of institutes over there. What was it like working there?
Oh, it was amazing. And particularly the group that I was a part of, it was led by an amazing scientist whose name is Helmut Dosch. He was the head of our group at that time. He's currently the head of B.Sc, one of the synchrotron sources in Berlin, in Germany, and in Europe generally, but I think it's particular to Germany. Instead of calling a department chemistry or physics or something, it'll be called the department of the head of that department. So we were in Department Dosch.
Oh.
It's a very strange system there. It's changing now. I mean, they've sort of started to more and more adopt to a more American style. But when I was there, you just have kind of the one professor and then a bunch of what are basically postdocs who work there, or research scientists. You can call them different things, but none of them have an official title. I mean, there was somebody who was working in that department. He'd been there easily 15 years, I think. And then when Professor Dosch left the institute and went to become the head of B.Sc, this guy went and immediately got a professorship position at another university in Germany, because basically he'd been a professor for many years,
Right.
but without a title, because that's just not the structure of that system. And the official title, I think, of Department Dosch became Low Dimensional and Metastable Materials. And he was actually one of the ones leading the change, Professor Dosch, about moving away from being his department to a department of collaboration and people working together rather than his vision, him being the face of it sort of thing, which is kind of cool. But it was great there. I think one of the greatest things about being there, though, was being there as a postdoc, because unlike many universities, Max Planck is very well funded. And Professor Dosch in particular was very open to collaboration and open to people giving their ideas. And so if you prompted him to say, I want to do this experiment, can you buy this piece of equipment? I did all the research. This is what it costs. This is what we're going to do with it. It was often that there was enough money for whatever you wanted to do, which usually my students are asking me, like, can we get 5 papers out of it? No, we can't. Oh, it's okay. I'm sorry. We can't do the experiment. I only have $10. Actually, we just had 2 new summer students start in my lab 2 weeks ago. And we were chatting and we're trying to build something in our lab. And my student had already been doing some of the research on it. And she was like, so there's one option that we could take that costs about $5,000, or I can build this thing for like $15 or something. I'm like, okay, so it's clear, right? She was like, I knew what we were doing anyway. I just thought I'd bring up that there's this other option. I'm like, yeah, okay, you know the story. Most labs are running on this like shoestring budget. And so it's not like that so much at Max Planck, which is amazing. But I'm really glad I went there as a postdoc, I have to say, because I looked at some of the PhD students who they were like, oh, I have this amazing idea. And then they would sort of make some notes about it and then send it off to the technician to have the machine built, and then send it off to this other person to do like a bunch of experiments, because we had 25 different machines that we could work on of diffraction and X-ray. Everything you can imagine, it's like under your fingertips kind of thing. And they would send it off to this technician and that technician, and they'd get a bunch of data. And then it would be so easy. They would just put all the story together, and then poof, there was this great paper. And I was one of the first PhD students actually of my professor at U of T, Dr. Liu. So we built the lab ourselves. He also had like a shoestring budget. And I really feel sympathy for him now, being in the position of the professor in that situation. where he's like, okay, here's a piece of twine, make the machine work, right? Like,
stick a gum and some duct tape, go.
Exactly. It's like, you can do it. This is a part of your training. Make sure that the machine doesn't break down, this 25-year-old machine that I bought refurbished. So that was my experience as a PhD student. And then so going into this luxurious Max Planck Institute where I could just drop by the store and just, oh, look, I want these 5 chemicals, and I would take them back up to my lab. It's mind-boggling. But if you were a PhD student going through that, going to any other lab anywhere else, you'd be like, what is this? But as a postdoc, it's like you're given the keys to the kingdom, really. I felt such creative freedom, and there was a mandate. I mean, I was a Marie Curie Fellow, which involved writing a research grant, and I had a small research budget of my own, and I had a couple of students that I got to train under that grant. So I had a particular vision of what I wanted to work on. But there was a lot of freedom to pursue it. And it was really inspiring to be there because the atmosphere was one of like-minded scientists, all collaborating, talking through different issues, having different expertise. And Max Planck, it's a metallurgical material science kind of institute, but it was also heavily physics. So Professor Dosch was actually a professor at the University of Stuttgart in the physics department. So there's a very strong fundamental physics approach and less engineering. So it was really great to have all these different kind of physicists, and there were some chemists, and I was working in organic electronics at that time as well. And the head of our group was from Spain. So we had a small group on organic thin films and its growth. And she was a material scientist who was really specialized in polymer physics and organic electronics and surface properties. And there was just so much ability to talk to people. And down the hall, there was a theoretician friend who I would go and chat about doing different calculations with. But it was really amazing. Like it was, I feel so blessed to have been given that opportunity. And I feel like it was this golden time where it was just amazing. The ideal place to be a scientist. It was great.
Definitely. And then you were able to actually have a visiting professorship position at Sabanci University in Istanbul, Turkey. So can you talk a little bit about what that was like, then making that transition, going from Germany to Turkey, and what you were doing there in terms of your science?
It was amazing, actually. So I'm Turkish by origins. I was born in Turkey. And I had this dream, I guess, when I was a child of becoming a professor. And then on my sabbaticals, I would go to Turkey and do science. So it was like a dream come true. And it was really because of Max Planck, because a colleague who was a professor at Sabanci had originally come from the same institute that I was at. So had come from the Max Planck Institute in Stuttgart. And we met and we started chatting and we started collaborating on a project. She sent one of her students over to work in my lab. We jointly supervised a master's degree together. So when my position ended, I went there. I went to work with them and we continued our same research project. Actually, I have to credit her because she's the one who introduced me to the approach that's kind of the bread and butter of my lab right now, which is a way of making nanoparticles in solution that are basically all the same size. And you can change the shape or change the size of it at will. And you can use it in any kind of material you can think of. And it makes these beautiful two-dimensional arrays of nanoparticles. So I started it at Max Planck. I did a little bit of it when I was with her in her labs, learning a bit more about the technique and everything. And then I brought it back to McMaster and then kind of branched out from what we had been doing, which was looking particularly at making nanoparticles to put into organic solar cells. And now we're starting to move into making things like sensors and batteries. And actually, we're going to use different kind of nanoparticles, but same technique to try to make antiviral surfaces to sort of fight against COVID-19 type viruses and stuff. So it's just opened up this world to me. So I really have to credit her for introducing me to that whole approach and allowing me to spend a year in her lab. So being in Turkey and being able to chat with the students and also teach in English. So I taught a couple of courses while I was there. It was like a dream come true. And I'm really glad I did it then, because after I came back to Canada after that, things went downhill a little bit for science and education in Turkey. The state of affairs now, I don't think I could have done what I did then. So I'm really happy I had that experience.
Well, it sounds like throughout your career path, you were sort of at the right place at the right time, which I think is amazing.
It's a fluke, I think, really. I never planned any of it. When I look back at the trajectory, it's pretty straightforward, right? I did my undergrad, I did grad school, I did a postdoc, I became a professor. Almost no breaks, no changes, nothing. It's just a straight path. It's like the ideal thing. But when I look back at it, all sorts of things were happening. All the stars aligned to allow me to do this and go there. And I met these people at the right time. But I think a lot of people have that experience where from the outside, it looks really easy and straightforward, but there was a lot of pieces that had to come together, and you have to sort of seize the opportunities when you see them or capitalize on what you learn or the people that you meet.
Definitely. And you sort of hinted at some of the phenomenal work that you are doing there at McMaster right now. So I'd love to dive into some more detail there. Is there a particular project, Ayse, that you are working on right now that you are the most excited about and want to share with us?
I'm actually working on a lot of really cool things. We're making really highly emissive nanoparticles from this new material called perovskites, which is a really exciting material. It's kind of a hybrid organic material. And we're trying to make super lightweight, very, very inexpensive and easily deposited nanoparticle arrays for making lasers for optical satellite communications, which is a really cool project, as well as we're making some sensors out of them. And I think right now, the most exciting project that I'm working on, it's really getting me to reach out of my comfort zone because we started a project using nanoparticles to make antiviral surfaces. So using the same approach that we usually make to make all kinds of nanoparticles, we're trying to use them to make an actively antiviral surface where the nanoparticles can break down the lipid layer around, particularly for COVID-19, like coronaviruses that have a lipid corona that are made up of sugars. And so we're trying to use nanoparticles that can actively degrade sugars to try to see if we can do something to make actively antiviral surfaces. And in particular, the target that we're aiming for is people are pretty conscious now about washing their hands when they touch doorknobs or that kind of thing when they come in from outside into their house to prevent the spread of coronavirus. But one of the things that people often forget is that these kind of corona type viruses, they tend to have a long lifetime on various kinds of surfaces, plastic surfaces particularly, and on paper and things like that. So when you go grocery shopping and then you bring that stuff into your house, and let's say you have a package of bread and you put it in your fridge, the virus can actually live on it for a long time, for up to 3 days, they say. And so our idea is to make this slow release antivirus surface where it will just actively destroy the viruses as it's sitting around in your house. So you don't have to worry about touching these surfaces. So that's what we're kind of aiming for, is to make an antiviral packaging material. So this is a really exciting project, obviously, and really scary because it's a new area of science that I don't know that much about it. And we're very lucky that we have some collaborators who know a lot about immunology and about how viruses work and have some experience with degradation properties. But I think one of the great things about this project for me is that it really showcases the beauty of material science, because my work on a day-to-day basis, making, say, lasers or making solar cells or making light-emitting diode and any of these kind of things, we're always trying to modify the electrical properties, so the band gap or the work function, these kind of properties. But the reality is that if you tune those kinds of parameters, you can also affect the activity on the surface, so how it reacts to chemicals. So you can use it as a sensor. It also changes how the dangling bonds on the surface will change how much it's going to change the surface energy. So you can make a surface hydrophilic or hydrophobic, depending on how you distribute your particles, for example. So really, some of these properties that we've been playing around with for a long time transfer very naturally away from the kind of organic molecules that we've been working on all the time to these more elaborate biological molecules or DNA and sugars. These things are actually also polymers or plastic materials to a certain extent. So it's really actually in our wheelhouse, even though it's a little scary. When I think about it, I'm like, oh, there's a whole world that I don't know. But at the essence, it's really not that different from what we've been doing for a long time. So there's this hope that we can make a contribution and do something that's not only scientifically interesting, but also makes some kind of benefit for humanity.
Oh, definitely. Well, Ayse, this is so cool and such an important area of research right now, as you alluded to. And I know you sort of hinted at these challenges with taking on a new area of research. And I know science is fraught with challenge. So we love sharing these stories with our listeners so they can appreciate what it's like to be a scientist and these everyday hurdles you go through, as well as these major failures that you may experience. So do you have a story of yours that you can share with us?
I feel like everyday science is a story of failure because you keep failing and failing and failing until all of a sudden you succeed, and it's super exciting. But I think there's one particular set of experiments in my life that in the end, it didn't actually turn out to be a huge failure, but it was traumatic at the time. But I remember it quite fondly because my family and pretty much everybody makes fun of me about it still because it's kind of hilarious. It was during my postdoc years when I was in Germany, and we had the opportunity to go and do some experiments at a synchrotron, which was about an hour away from our labs in Stuttgart in Karlsruhe. And a synchrotron is just a really high energy electron source, basically. And we were using it to do X-ray diffraction. And it was very common for my group to go to this beamline. We often worked there, but it was still very challenging to get time on the machine because it basically runs 24 hours a day and many people are doing experiments on it. And so you get a very limited window. You only get like a few hours or a few days access to go and work at the beamline and do your experiments. You plan for months in advance to have these experiments, you know, the date you're allowed to go there. And then you work 24 hours a day when you're there, usually in shifts with other people, and you sleep on site. Like, it's a really intense experimental time. So I was building up to my very first one. I have this amazing idea. I got this time slot. I'm going to go and do my experiments. So I've been planning for ages, and I was working around the clock to get my samples ready. And my colleagues had already gone up the night before, and I was still in the lab, like getting my samples ready because they had to be fresh to do the experiment that I was interested in doing because they were degrading over time. So I stayed up all night. I was crawling all over the machines, getting all of my samples ready. And I drove up to Cultura the next morning. We set up everything. It takes a couple of hours to sort of set up the experiment. Everything was set up. It's running. I went off to dinner with my colleagues. We came back and it was a disaster.
Oh, no.
Nothing had happened. I was distraught. I was like, oh my God, we came all this way. What's going on? And then I went back to my room at the guest house and I sat on my bed and the bed collapsed underneath me. The bed broke. No. I was like, oh my God. And apparently I called my parents and left this confused, rambling, garbling message where I was crying, being like, the German government is paying me to be here and I failed as a scientist and my bed broke and I can't even do anything and I should just go home. So then I slept. And then I woke up the next morning and we were talking to the technician and apparently a transformer had exploded in the system and the beam had gone down, but nobody knew about it. It was a really large transformer. I went and looked at it later, but it was kind of in the middle of the night and nobody really knew about it until the next day. So everything had crashed. The whole beam had crashed and it was this big deal that the transformer had blown. And the technician is like, this hasn't happened ever. We've never heard of this thing. It's once in a lifetime thing. This transformer exploded. And then as an aside, I went there again 4 or 5 weeks later and again a transformer exploded. So the technician started telling me that I was not allowed to come back because I'm causing the transformers to explode. But anyway, once they figured out the transformer had gone, we sort of reset the experiment, did a bunch of things, and I got some data. It wasn't as earth-shattering as I would have liked, but it was at least data. So this is my traumatic story of science. But I think the lesson that I really learned that day was sometimes you just need to sleep on it, step back, gain some perspective, and then just try again because it happens. Science is not about getting that one key experiment which revolutionizes the world. That would be great if every day was like that. But most of the time, it's a constant series of failures. And then finally, you're like, oh my God, we did something. Or you change your mind, right? You can also say, well, clearly that was the wrong idea. Let me go and come at it from a different perspective. So that's really how I try to take it in stride. But I think back on it fondly now, but it was traumatizing.
You can laugh in hindsight.
Exactly.
Well, thank you, Ayse, for sharing this candid account of this moment where literally everything was falling apart. And I think you brought up a really good point that in these moments, sometimes it's not a good idea to sort of put your head down and keep working. You just sometimes need to step back and not touch anything for a little while. So
I think during my doctorate years, there was a piece of equipment in our lab that we used all the time. And Friday afternoons, it would turn off. If you started an experiment on Friday, it would never work. We always used to say that she was temperamental and she needed to take the weekend off, basically, right?
Right.
But there's definitely times in science where if you just try to push through, it'll just make everything worse. I remember that one time when we were working on, again, this piece of equipment during my doctorate, and I was like, okay, it's Friday. We should probably go home and we'll pick this up again on the weekend. And then there was another student who was like, no, I really need this data. So let's do it. So we tried. So we were working on things and we set everything up. And then, of course, the anode melted. And then we had this vacuum chamber and it started leaking water into it. The whole thing flooded. Everything was a disaster. And then we had to recover for about 2 weeks. It took us 2 weeks to get it back up because it's a high vacuum system. So it took us 2 weeks to get back to a good vacuum. Water is not your friend when you work in vacuum.
Right.
But if we had just not done it that day, if we had stopped taking a look, because if we had looked at the anode, we would have seen that it was going to burn out. I mean, you usually can't predict that kind of thing, but it was around the regular maintenance time. And if we hadn't pushed it that day, I think we probably could have just done the experiment on Monday and it would have been fine. But there are times when you're under so much pressure and you have to get the result, or next week is your committee meeting, or next week you have this paper due, or some funder is expecting results, or the company is pressuring you. And sometimes you just are like, I got to do it. I have to do this experiment. But if you just stop and take a step back and think about it, you can avoid disaster and or get much better results if you take some time.
Absolutely. Well, I think it's so helpful for our listeners to hear about some of these struggles that you've encountered because they may be going through the same thing right now.
I'm telling you, it's all failures until it's a success.
Well, I'd love to talk about these successes as well. So, Ayse, is there a particular success story you want to share with us, whether it was a big win or just a meaningful small victory?
There is one. Recently, I took a student and we went to Austria to visit a lab, some close collaborators of ours. And we had, again, a short window. It's always like you have 5 minutes to do an experiment, basically, and you have to cram as much as you can into it, right? So we were there for 3 weeks or so to do the experiments. And we had done some preliminary experiments back in Canada in our own labs, and it looked like it was pretty promising. But the results weren't good enough to publish. So we were going there to sort of confirm our results and then get a nice spectrum so that we could put it into a paper. And the student and I, we were working, again, we're trying to get everything going. We have short time. So we were working to get everything frantically, made some samples, and then it didn't work.
Oh, no.
We worked on a couple of other things, and he kept trying and trying. It was a sample prep problem. It's very finicky, and you have to be very careful about it. So he kept trying and trying. And then finally, on like the second to last day before we left, and in fact, I left him and went to the Czech Republic. So I even left the country because we were going to visit some other research institutes. So I was like, okay, you have a couple of days here, then we're going to wrap up and go home. And then maybe it's because I was gone, I don't know. But while I was gone, he managed to get this thing to work. And he wrote to me, he's like, I have it. Here's the spectrum. And I was like, yes! It was so exciting. I have amazing students. They work so hard and they're so dedicated to what they're doing. And it's so gratifying to see when they succeed. And sometimes you can beat your head against a wall when you're not sure. But in this case, we were pretty confident. But I have to say that my student was more skeptical than me that it was going to work, actually, because he was like, are you sure these results are real? I'm like, I think so. They look good. Let's try it in Austria. Let's see if it works. And when he got them, he was stoked. It was so exciting. It was like the cherry on top to end up our visit, which was super productive and fruitful otherwise as well. And so it was just like, amazing.
Well, congratulations to you and the student on this success. I think it's so important to take that moment to kind of appreciate, to enjoy that sigh of relief when you get one of these big successes.
Absolutely. Sometimes it's really gratifying. You're like, yes.
Definitely. And I know as a scientist, you are working so hard in the lab. You're often immersed in the literature, just kind of keeping up to date with everything that's going on in your field. But we like to encourage our listeners to read for fun as well. So I love giving everybody book recommendations that they can put on their own reading list. So Ayse, do you have a favorite book, whether or not it's related to science, that you want to tell us about today?
I love to read. I read every genre, mystery, science fiction, romance, everything. I love it. I encourage everyone, read as much as you can. It's amazing. But one of my favorite books really is How to Travel with a Salmon by Umberto Eco. And it's really cool. It's a series of short nonfiction pieces that he wrote. And it's really about sort of the absurdity of bureaucracy and the absurdity of people. I mean, Umberto Eco his official title is semiologist. He's a linguist of sorts, or he works in language in Italy. And he has a real amazing grasp of language, and his turn of phrase is amazing. It's like the most well-written thing I've ever read, but also the topic and the way he describes it is amazing. The title story, which is How to Travel with a Salmon, is all about him being gifted a salmon. And he was on a tour of different universities giving lectures and stuff. And so he was traveling with the salmon, trying to figure out how to store it. And he would fold it, put it into the refrigerator at the minibar at the hotel. And you have to pay for minibars at the hotel at that time. Like, it was just, the whole story is absurd. It's amazing. And he lost his driver's license, for example, and he had not had the foresight to make a photocopy. And he kept trying to get a new driver's license. And everywhere he went, every bureaucrat was like, well, do you have a copy of your driver's license? And he's like, no, I lost it. That's why I want to get it. And they're like, well, if you don't show us a copy of your driver's license, we can't possibly help you. And it's like this sort of inanity of bureaucracy. It's just amazing. So they're hysterical and yet sad and absurd about how we get in our way a lot. And so he's amazing. He has an amazing insight into humans, and also his writing is fantastic. So I would highly recommend How to Travel with a Salmon. I think it was published in the 1980s. But if you can get your hands on it, it's well worth a read. The second one is one of my favorite plays. It's also kind of absurd. I'm a big fan of French theater from the 1940s, 30s. And my favorite play is called 6 Characters in Search of an Author. That one is by Luigi Pirandello, and it's a play. I mean, it's a weird way of reading sometimes, but I like to read plays as well because I'm very interested in theater. But it's, again, about the absurdity of people and the interactions. And so it's kind of a meta commentary on authorship in a way, because the author wrote these characters and the characters kind of rebel against the author and are trying to find a better author, basically, than the current author. So it was this crazy absurdist play. That kind of thing really speaks to me. Also, one of my favorite books really of all time, and I reread it from time to time, is called By the Sword by Mercedes Lackey. So she's a fantasy author, and this, again, is a very old book, but it's also one of my favorites. It's really the story of a young woman who becomes a warrior and becomes the head of a mercenary band, and it's just her arc from a young woman into her sort of old age, and it's like classic fantasy. And I love Mercedes Lackey. I read her since I was a small kid, and people often will sort of disparagingly call genre fiction sci-fi and fantasy and mystery. and romance. I'm a huge fan of romance. My wife always makes fun of me. She's like, oh God, are you reading that crap again? I'm like, yes, I am. And I'm loving it. It's amazing.
I'm proud of it.
Super proud. Though I have to admit that when I was a kid, I did get one of those book covers that I think my parents gave it to me for my birthday one year, which it has like an embroidery on it that's like smutty book. It's like a cover so nobody can see the like lurid
Right.
cover of your book that has bodice ripping kind of situation going on. But yeah, reading it's another way, I guess, of seeing the world.
Oh, I couldn't agree more. I think reading gives you the opportunity to kind of approach things differently, look through a different perspective. So we appreciate you sharing these recommendations. I will add How to Travel with a Salmon, 6 Characters in Search of an Author, and By the Sword to our book list on our website for our listeners to find. And we've touched on travel as well earlier in our conversation and some of the amazing opportunities you've had to go different places for science. Do you have a favorite place that your science has taken you?
It's hard to say that there's a favorite place. I've been so lucky to travel to so many places, both for science, but also in general. But I think I have 2 stories, I guess, that are science or science adjacent. I think one of them, before I went to Sabanci for that visiting professorship, I was on the thesis committee of one of the students there. So my colleague invited me from Stuttgart and I flew over to Istanbul and we were at the defense. And then my friend was like, we should really go and have Iskandar. And it's the special kind of doner, which is really famous. And there's a place where it originated. And he's like, we should go to the original shop. Let's go to Bursa. So we like drove for an hour for no reason, just so we could have this meal. And all the members of the thesis committee were there. The student came with us too. We all just went and it was fun. We just had this great time. We all piled into a car. There's a route that you can drive for like 2 hours. And if you take the ferry, it takes an hour or something. So we like waited for the ferry and it was super hot. And it was just like, it was completely ridiculous because I had arrived that morning. I think I was leaving that night on a plane to get back. And in between, we're like, let's take a random road trip.
Great adventure.
And so to me, it's always the people that I meet. And there's another time when I was in Cancun for a conference and I had a Mexican colleague who knew that area really well. And so he took me to like a really authentic taqueria that was outside of Cancun. Oh God, I think everything's about food now. But anyway,
it's almost lunchtime.
So those kind of experiences where it's just being with the people who know that area and you can just chat about science, about life, and they're just up for crazy adventures. I always feel scientists are up for crazy adventures all the time. But I think my favorite kind of a science adjacent trip, I'll say, but it was really meaningful and powerful for me personally, is I went to Brussels to a conference and I took the time to go to the Atomium. So I don't know if you've heard of the Atomium. The Atomium is this gigantic building / science museum that's in the shape of a body-centered cubic unit cell. I think it's supposed to represent iron and basically looks like atoms that are arranged in a particular order. So they have this particular shape. And it was erected for the 1958 World's Fair. And as a science museum, it's cool, that kind of thing. But it's particularly special for me because my father had a replica of the Atomium on his desk. And I saw this all the time when I would visit him. And I love this thing because it's really cool looking. And it's even more special because my grandmother, so his mother-in-law, gave him that as a gift because she went to that 1958 World Fair.
Oh, cool.
And he had gotten this thing. And because he was a scientist and she was very proud of him, so she gave it to him. And so it's hard for us now to think about it, but there was a lot of excitement about the future in the 1950s in a way that maybe we don't feel as much now. So there was a lot of celebration of science and knowledge and this amazing material breakthroughs and all this kind of stuff. So this Atomium thing sat on my father's desk and I always used to be very enamored with it. And then I bought a replica for myself and I kept it on my desk in Stuttgart. And then when I got my position at McMaster, my father gave me his.
Aww.
So now I have both of them sitting on my desk. So it connects me to my family, to my history, to science. It sort of represents a lot to me. So being able to actually visit the Atomium and see it for myself was really, I think, one of the most special experiences of my life.
Oh, that sounds like an amazing opportunity. And like you said, sort of a meaningful icon personally for you in your life. And you've mentioned throughout a lot of these stories that you shared with us, some of these great people that you've worked with. And I think for me, at least, so many of the scientists that I know are these creative, funny, wonderful people, but that's not often how we're perceived or portrayed. So we try to break those stereotypes on our show by showcasing the human side of science and some of the funny things we do, the quirky traditions that spring up. So Ayse, do you have a particular memory that goes along this human side of science line that you can tell us about?
To me, the part that's the most exciting part about science is the people. I've been so privileged to meet such interesting people and doing some crazy things. I think my experience in Stuttgart particularly always stands out for me because it was such a creative, fun time. And people there were super fun. And we used to go to the beer festival as a department, and we would have parties where people would dance all night. It was amazing. It was great. People would bring food from their own cultures and everyone would share. But I think the quirky lab tradition that springs to mind is a more recent one where we went to visit these colleagues in Austria, as I mentioned. And I had actually been in this lab previously. I'm very privileged to have worked with these people for a long time. And in that lab, their tradition is that whenever a student graduates, either undergraduate student or master's or PhD, or a postdoc finishes their extended stay or something, they have to close their eyes and turn around and then throw like a dart or a pen or something into the ceiling. And then wherever it lands, they draw a little circle around it and write the name of the person and the date that they finished, basically. So it's really how this professor, Dr. Sarchipje in Linz, Austria, at the Johannes Kepler University, this is how he keeps a record, like a tangible record of who's been there. And I think they renovated or they moved their labs, but he had all the pieces cut out and put on the wall. So they're all framed now, all the old pieces. And now the new students are making new divots in the ceiling. And it's just, people are crazy, but it's really touching. Like I find it really special. And my student who was with me at the time, he's like, oh, that's so cool. We should do that. I'm like, we don't have a room where we can.
We're going to have to call facilities. Yeah.
Yeah, exactly. That would never fly. We need to be much more impressive people to have our own room that we can deface in this way. But I always aspired to be that kind of supervisor. I felt that also when I was in the Max Planck Institute. I think it's that there are certain labs that you're in where it's just a joy to be there. And the people are enjoying themselves so much. And the science is amazing because the people are feeling so much joy. So I always hope to bring that kind of thing back to my own lab. I know you'd have to ask my students if we're doing any quirky things, but I think mostly they think I'm kind of nuts. I always want everyone to feel an extreme joy of science. We're here together solving these problems because we want to be, and it's fun. It's about the fun of it. And that's what I feel, that experience where those people were so happy to throw those pens in. It's so meaningful to them because being in that space gave them such a sense of joy, I feel.
Definitely. And I think you brought up a really good point that having this environment that you can work in where there is that excitement, that joy, just culminating in that creativity, I think can be so important in science because you have this environment where people are encouraged to work together to form that camaraderie, and you can do some really amazing things when you have that there. And there are many big problems that remain to be solved in science and in your field in particular. And oftentimes things stand in your way, Ayse, whether it's funding, staff, technology, feasibility, ceiling tiles, whatever the limiting factor might be. So if we gave you anything you could dream of, what is the big question you would want to answer first?
I think if I had no limitations and there was no issue, the thing that I would like to solve is how can we make solar energy basically unlimited, ubiquitous, and accessible to everybody? How can we cover every possible surface with solar panels? That's really my goal in life. That's really what I'm doing with my research in a way. That's sort of my passion. And I really want to make energy affordable and accessible to people in a way that doesn't destroy the world. The fossil fuels exist and they are a necessity at this moment, but there are so many other ways that we can power the world that it kills me that we can't do it. And there are technological reasons and there are scientific reasons. And if I had all the money in the world, that's what I would spend all of my time doing, is trying to find a way to make energy available to everybody everywhere.
Certainly. Well, Ayse, definitely a worthy cause. Thanks for dreaming big with us on the show today. And you have shared so much in terms of your own personal experiences, your stories, your insights. I'd love to end with some advice. So when you think back on your own career and experiences, is there a particular piece of advice that was so helpful that you can share with all of us?
I think the biggest piece of advice that stuck with me when I was hearing it, and also I try to apply it in my own work and my own group, is that my doctoral supervisor once told me that the person doing the experiment should be the expert on the project. It shouldn't be the supervisor, the head of the lab. It shouldn't be any of those things. It should be the person who's doing it. And I feel like part of my job is to learn from the students, from what they're doing, and for them to be the experts and for them to teach me what are the important questions, what needs to be solved here, what's interesting, what's coming out of it. And if you can learn things from your students, then everybody's doing the right thing. They're learning, you're learning, everybody should be learning. And so that's the biggest piece of advice that I ever got.
I love it. Well, excellent advice. Is there any other last piece of advice, Ayse, or a last note of inspiration that you'd like to leave us all with today at the end of our call?
I guess the only thing I would say is that you should never stifle your curiosity. Your question is never invalid. You should always ask questions. You should always push back. If an authority is telling you something, you should question it and ask why and how and prove it to yourself. So you should hold on to your curiosity at all times. It's never wasted and it'll always take you somewhere interesting.
Wonderful message. Listeners, definitely stay curious out there. Ayse, it was such a pleasure to have you with us on the show. If our listeners want to learn more about you and your work, what is the best way for them to do so?
They can visit my website. It's organic electronics, all one word, .mcmaster.ca. Or they can always reach out to me by email. My email address is turaka@mcmaster.ca. So TURAKA @McMaster. I'm always happy to hear from people and hopefully people will reach out.
Excellent. Well, listeners, definitely get in touch if you want to learn more or if you have any questions. And Ayse, we appreciate you spending time with us today. Thank you again so much for being on the show.
Thanks for having me. It was lots of fun and it's really interesting to think about these things. I feel so privileged in my life to have had the kind of experiences I've had. And I'm also really privileged to have other people be interested in them. I guess I can talk about them for hours, as you can see. So.
Me too. Listeners will continue after this. Well, Ayse, again, thank you so much for your time. Listeners, great to have you here as well. We'll see you next time on another episode of People Behind the Science.